All right. Hello, everyone. Today we're taking a look at complex numbers, um, more specifically, pure imaginary numbers. Okay. And our study so far, you have worked with real numbers. Okay. We kind of talked about this earlier in the semester. All numbers we knew to that point were all real numbers. Okay. So today we're going to learn about imaginary numbers. And what the imaginary unit is. Okay, so the imaginary unit is I. Okay, it's defined to be I squared equals -1. Or more specifically, if you're just worried about I, it's I is the square root of -1. Okay, numbers of the form 6i, -2i, and I radical 3, those are called pure imaginary numbers. Okay, pure imaginary numbers are square roots of negative real numbers for any positive real number b. Okay? And so we can use this new information to simplify square roots of negative numbers. And so I'll show you a few examples of that. Okay? If you're looking at example A here, we've got the square root of -27. Okay? To simplify the square root of -27, you are going to want to think of this as, you can think of it as the square root of -1 times the square root of 27. Okay, of course we know the square root of -1, guys, that's what we just defined to be I. Square root of -1, that's equal to the imaginary unit I. So this is just I times the square root of 27. Use my eraser here. 27, not 7. Sorry. All right, I do want you guys to be able to reduce the radical, the square root of 27. One way to do that, you might remember this from your Algebra 1 class. If you do the prime factorization of 27, okay, 3 times 9, and then break that 9 down into, again, just all prime numbers, okay, pairs would come outside of the radical. The leftover prime numbers would stay in. So we'd have 3i square root of 3. That would be the simplifying of the square root of -27. Okay. If you didn't quite catch the breaking this down, doing the prime factorization, guys, another way to think of the square root of 27, maybe a little more efficiently. This is the method I kind of prefer. Okay. Think of 27 as the square root of 3 times the square root of 9. Okay. We all know the square root of 9 is 3, so that's where that 3i comes from. And then the radical of 3, of course, that can't simplify, so that just stays radical 3. Okay? So that's how you simplify a negative square root. Okay? Looking at square root of -216. Okay, it's going to be kind of this same idea here. Okay? We'll think of the square root of -216. Think of that as the square root of -1 times the square root of 216. Okay? Square root of -1 is I times square root of 216. So we got to simplify 216. So again, you could look for perfect squares that go into it, or you can do the prime factorization. Let me show you guys that prime factorization idea again. So we could be looking at, what, 2 and 108? If we're trying to find a prime number that goes into 216, 2 does. 2 and 54. 54, a prime that would go into 54 might be 2 and 27. Well, then we got 3 and 9 again. And 9 is 3 and 3. So, simplifying this, okay, you've got a pair of 3's here. So we've got I times 3 times, we've got a pair of 2's. And then it's going to be times the square root of 3 times, we had a 2 left as well. Okay, so this is 3 times 2 is 6 I radical 3 times 2 is 6. 6I radical 6. Okay. So there's your example B. All right. 1A. I'd like you guys to try to work that one out. I will give you the solution here. It actually ends up being 3I radical 2. Okay. And 1B will do similar. Oh, apologize because my scrolling. I have a tough time, guys. The solution here for the square root of negative 125 is 5I radical 5. Okay. So trying those two be good practice. All right, taking a look down here, guys. The commutative and associative properties of multiplication, they hold true for pure imaginary numbers. Okay, it doesn't matter what order you multiply in. Okay, guys, these first four, this top column is important for you guys because I'm not hugely worried about that bottom column, but this top column describes I to different powers for you guys. Because I to the power of 1, that's just I. Okay, I squared, guys, if you think about what does I squared mean, that is I times I, which would be the square root of negative 1 times the square root of negative 1. Okay, the square root of negative 1 squared is just equal to negative 1. Okay, so I squared is equal to negative 1. Okay, so then it would stand that I cubed, guys, I cubed is, well, it's I squared, which we just talked about was negative 1 times I. Okay, I squared negative 1 times I. So I cubed simplifies to negative I. Guys, I to the power of 4 is just equal to 1. It is I squared, which is, again, I squared is negative 1 to the power of 2. So that is why I to the power of 4 is just positive 1. Okay, guys, we'll use these properties to take on the second page, simplifying products of pure imaginary numbers. Okay. So, if you look at, apologize here. If you look at example A here, we're simplifying negative 5I times 3I. So it's just going to be negative 5 times 3. We're going to multiply the real numbers, and we're going to multiply the imaginary units here. So negative 5 times 3 is negative 15. I times I is I squared. Guys, remember on that chart, the last page, I squared was equal to negative 1. So this is negative 15 times, well, I squared is negative 1. Guys, so negative 5I times 3I simplifies to positive 15. Okay? Guys, so if we take a look at example B, okay, it's going to be a similar type problem here. Let's simplify, let's think of this as, well, square root of negative 1, or I times the square root of 6, times, this would be I times the square root of 15. Okay, so this is I squared times the square root of 6 times 15. What do we get? We get 90. Okay. And then simplifying the square root of 90, guys, we'll go square root of 9 times square root of 10. So this is 3 radical 10. Okay, so this is 3I squared radical 10. Guys, I squared being negative 1, so this is just negative 3 radical 10. Okay. So there's two examples, guys, 2A and 2B. They're pretty similar here. In fact, I'll just give you guys the solutions, much like on that other page. Okay, 2a simplifies to negative 12. 2b simplifies to negative 4 radical 15 when it's all said and done. Okay, 2c, guys, pretty not familiar. We haven't seen one like this yet. Okay? Guys, the whole point here is we know what I squared is. We know I squared is negative 1. Okay? Using your properties of exponents, you know that I to the power of 31. Guys, you could write that as I squared to the power of 15. Guys, that would give you I to the 30th power. Then you would multiply it by I. Guys, again, properties of exponents says this is I to the power of 32 times 15. Power to a power, you multiply them. Okay, so this is really just negative 1 to the power of 15. That's why we chose I squared. We know it's equal to negative 1. Okay, times I. So negative 1 to an odd power, that is just negative 1 times I. So I to the power of 31 simplifies to negative I. Okay? Guys, taking a look here at the last couple of problems, guys. Solving equations with pure imaginary solutions. This equation, guys, if you're trying to get x by itself, you're going to subtract 64 from both sides. You've got x squared equals negative 64. Guys, to solve this, you square root both sides of the equation. Because that's going to give you x equals plus or minus square root of negative 64. Of course, we now know how to simplify that square root of negative 64. This is plus or minus I square root of 64. Guys, the square root of 64 is just 8, so this is plus or minus 8I. All right? And so the last example, guys, pretty similar. Your solutions here, x equals plus or minus 2I. I'll let you guys kind of try to work that one out and give you the solutions there. All right, guys, thanks for watching. Hope you find this DLD, this video, useful. Okay, don't hesitate to reach out with any questions.